welcome everyone to this live today. I've got Eric Trexler with me today, and he is a PhD, a pro bodybuilder, researcher, coach, and also he is one of the main directors of the education for MASS, for research review. So I am so pleased to have him on today, and I've got a lot of questions that we're going to discuss. One of those is about metabolic adaptation. We're going to talk about leptin, ghrelin, appetite, TEF, and also some of these things that we might find a little bit confusing when it comes to sports or amenorrhea in women when they're very lean. So let's get him on. Hi, Eric. How are you?
Hello, I'm good. How are you doing?
I'm very, very excited to have you on.
Can you hear me okay?
Yes, perfectly fine.
Awesome.
Well, I think most of the people that is joining this live probably might know you, but for those who don't know you, can you tell us a little bit of a short story of who you are?
Yeah, so my name's Eric, obviously. I did my PhD in human movement science. When I was doing research during my PhD, a lot of it was on dietary supplements, but a lot of it was also related to metabolic adaptation, and competing as a natural bodybuilder got me interested in that topic. So I've done some research on how metabolism changes when we lose weight and try to get super lean, as bodybuilders do. And nowadays, I'm the Director of Education for Stronger by Science. Greg Nuckols and I run the site over there. I'm in charge of our coaching program there. I coach clients myself. And then I'm an author for MASS, which is a monthly research review with Greg Nuckols, along with Dr. Eric Helms and Dr. Mike Zordo. So that's how I spend all my time these days.
That's awesome. Pretty much wanted to get you on to talk a little bit about metabolic adaptation and some of the relationships between certain hormones and how they change during the course of these adaptations that your metabolism tends to do or respond towards dieting or calorie deficit. So I know you wrote an article, very long article on metabolic adaptation. Do you find yourself that anything that you wrote back then has changed over the course of these few years?
That's a really good question. You know, I don't think much about metabolic adaptation has changed in the last few years. I think maybe you could argue that we've learned a little bit more about refeeds and diet breaks in the time since. I'm waiting for a couple studies to come out. I know that the studies have been done, but they haven't been published yet. Once those get published, I'll probably go in, and on Stronger by Science, we do updates to our articles. You know, if we learn something new, we go in and we say, hey, here's some new stuff. We don't edit the article after the fact, we just add more. I'm probably going to add more about refeeds and diet breaks eventually, because I think I've seen some data within the last year or two, like I said, much of it not published yet, that has caused me to have a little bit less optimism about exactly how effective they might be. I still think there's some use for them, but my excitement has come down from very high to moderate, I would say, when it comes to refeeds and diet breaks.
Okay. Is there anything else that you find that has changed, perhaps like in the role of hormones or certain things that probably have evolved over the past few years? Or do you think that your stance is pretty much the same when you wrote that article?
No, I mean, that stuff is pretty much the same. And I mean, a lot of that research wasn't even new at the time that I wrote about metabolic adaptation. I mean, a lot of that research is at this point 10, 15, 20 years old. And I really don't see it changing. I don't think there's really much of a window for that. We might, you know, add a little bit of information here or there, but the general concept of metabolic adaptation, I think, is kind of a reality of energy restriction. I think we've really figured out most of the basics, and it's really just filling in the little details, maybe refining our estimates of exactly how large the adaptation is. But I think a lot of the basic premise of metabolic adaptation is pretty rigidly set in stone. The place where we see a lot of potential for future knowledge gains, a future shift in perspective is what we actually do about it. So like I said, how might we most effectively utilize refeeds and diet breaks? A really interesting concept is exogenous weight replacement, so using weight vests and things like that. I think we can get a better understanding of what to do about it, because right now we don't know much aside from just injecting leptin. But yeah, I think that's an area where we have a lot of room to grow.
That's awesome. So let's get into a question that I get a lot, and basically is that people don't really know what metabolic adaptation actually means, and some people refer to it as adaptive thermogenesis, or whether that's the same as mitochondrial efficiency. Is that the same, or are there any difference between these three terms?
I think it's, unfortunately, there's not like universally accepted definitions of like what is metabolic adaptation. You'll see people use that term a little bit differently in different contexts. So I like to talk about metabolic adaptation as kind of an overarching syndrome. So adaptive thermogenesis, or the reduction in energy expenditure that is adaptive in nature, is absolutely part of that. That is a kind of defining characteristic of metabolic adaptation, but I think it's short-sighted to look at metabolic adaptation as just a drop in total energy expenditure, or some people will even look at it as just a drop in resting metabolic rate. I think you're missing a lot of the really important physiological context when you just look at that one aspect. And when it comes to mitochondrial efficiency, that's looking even closer. I mean, that's like looking at a single aspect of metabolic adaptation. So with metabolic adaptation, do we see a reduction in resting metabolic rate? Absolutely, and that might be referred to as adaptive thermogenesis. Is increased mitochondrial efficiency part of that drop in resting metabolic rate? Definitely. So you can see these as kind of a hierarchy of terms rather than synonyms. Okay,
got it. And what does that mitochondrial efficiency means? When you hear that term, a lot of people get scared. What does that mean exactly? What is that?
So mitochondria make ATP, and there's a caloric cost associated with that. And so a really basic way to look at it is when we have high mitochondrial efficiency, we can make a lot of ATP without burning as many calories in the process. When we have low mitochondrial efficiency, we're burning all sorts of calories for a given amount of ATP production.
Okay. That makes much sense, especially when people hear these terms that probably seems a little bit more sophisticated for some people that might not know very much about metabolism or the anatomy or physiology. So it's good to explain those things. Now, how many days into a deficit you can be pretty much before you actually feel like this sort of metabolic adaptation starts to kick in?
Well, ultimately, it's going to depend on the size of the caloric deficit, right? So the size and the magnitude of the energy deficit. So in fact, if you just start fasting, we're going to see drops in leptin within hours. And then those become much more pronounced over the course of, when we go with really low caloric intake. Over the first 3 or 4 days even, we might see some pretty big reductions in leptin. And so as leptin falls, that's kind of the impetus for what we call metabolic adaptation. So, different aspects of metabolic adaptation are going to follow a different time course, but ultimately that drop in leptin means that we are starting the process, right? So we're going to see that drop in leptin, and eventually that's going to reflect, it's going to be reflected by reductions in non-exercise activity, thermogenesis, reductions in resting metabolic rate, changes in some hormones eventually, certainly changes in appetite-related hormones. So we're going to start to see really over the course of only a few days some of these changes that are all related to a drop in leptin.
Okay, got it. And now, especially when people do like very short cuts, do you think, are they able to get away from these metabolic adaptations in the first few weeks? For example, if someone is doing a cut 8 weeks, 6 weeks in, how much of that metabolic adaptation can affect that person?
Well, there's two main drivers when we look at these different aspects of metabolic adaptation. There's the acute short-term magnitude of the energy deficit. And then there's the more chronic approach where we look at changes in fat mass and fat-free mass. So there's the short-term stuff that's all about energy availability or the short-term energy deficit. Then the longer-term stuff, we talk about how the loss of tissue starts impacting some of this stuff. So when we look at those short cuts, ultimately we see that in order to make those cuts work, we need to have a relatively larger energy deficit to achieve the same amount of weight loss in a shorter amount of time. So no, it's not some type of thing where, I think sometimes people get the impression that as long as they're not cutting for a long time, they're not going to run into any of these adaptations. So they go, cool, I'll go really extreme for a short period of time. That's certainly not going to alleviate or avoid any of these issues. And if anything, could potentially exacerbate it, because the actual size of that deficit is so big, you start to see a huge reduction in energy intake. You have a huge caloric deficit, leptin drops pretty precipitously, and we start to see some of these impacts. And you can even just look at the short-term overfeeding and fasting studies and see, very short-term overfeeding causes this huge increase in energy expenditure. And much of that is adaptive in nature. And when we look at short-term fasting studies, we will see, in some cases, a drop in energy expenditure, especially if it's not fully fasting, but just low caloric intake for a few days. We'll already start to see some of those drops in energy expenditure. So unfortunately, you can't cheat the system by just going really aggressive really quickly.
So do you find, is there any factor or variable of metabolic adaptation you could pinpoint that it could be the starting point or the trigger of that cascade for the body to perceive, well, it is time to adapt, it is time to survive, and it's time to sort of make some adjustments? So is there something that actually triggers it?
Yeah, so there's two main drivers. We've got the loss of body mass, whether that's fat mass or fat-free mass. Those both play a role. And then also, as we've talked about, the size of the acute energy deficit. Both of these lead independently to a reduction in leptin, which is a hormone that is, it fluctuates throughout the day based on energy status, but also fluctuates based on how much fat mass we have. And so when we see that we have a reduction in fat mass and we're in an energy deficit, especially if it's a large energy deficit, leptin goes down. And leptin is perceived by the hypothalamus, a region of the brain where there are a bunch of leptin receptors. And when the hypothalamus starts to really pick up on the fact that leptin levels are low, it responds. And the hypothalamus is responsible for coordinating just about everything we would care about when it comes to energy intake and expenditure. The hypothalamus has an impact on how much energy we burn at rest, our general activity level, our hunger and appetite. I mean, the hypothalamus is really dictating a lot of these different things. And so that really is the initiation. We have these two drivers that cause a reduction in leptin. The hypothalamus senses that reduction in leptin, and then our energy intake and energy expenditure are impacted by that.
Would it be a long or very large body weight reduction also triggering that? Like, for example, like let's say someone takes a very restrictive approach, these sort of crash diets that they can lose up to 5 pounds or 10 pounds within 2 weeks. Would that be an important driver as well for this leptin and these hormones to sort of perceive that something's going on?
Yeah, that would certainly, any kind of really big deficit, even in the short term, is going to cause a reduction in leptin. Then, of course, independently, if this weight loss attempt actually works, then they will lose fat mass. Those fat cells that used to be full of energy now are empty a little bit. When we start burning through body fat, we're emptying out those adipocytes, those fat cells to some extent. And so when fat cells are full of energy, when those adipocytes have a ton of caloric content within them, stored within them, they make a bunch of leptin. And when they start to get emptied out over the course of fat loss, they start producing less leptin. So we've got both of those things driving metabolic adaptation. Now, one of those things will be alleviated once the diet's over, right? So let's say we go on a very aggressive diet, for 3 or 4 weeks. We have a huge caloric deficit every day, and we lose a bunch of fat mass in the process. After that fat loss is done, we can then reintroduce calories and get back to maintenance. So now that big energy deficit is no longer a problem. It's no longer driving any metabolic adaptation, but we still have to deal with the fact that we have lost a bunch of tissue, specifically fat tissue. And so there will still be probably some degree of metabolic adaptation present at that point, but going from a huge deficit to energy, to maintenance calories, even with the fat loss, is going to have a nice positive effect in terms of alleviating at least the adaptation associated with that big deficit.
Okay. Following up to that you mentioned already, is there some, like when you have finished your fat loss, for example, and you start reintroducing calories, why do we see in some people that leptin even sometimes takes so long to recover? Especially if you've been in a deficit for that long, and you're still finding people that struggle to increase their BMR, even if they are actually out of the diet for a while.
Yeah, well, ultimately, like I said, the leptin is made by the fat cells, and the degree of leptin production is dependent upon how full they are. So to some extent, if you want to get your leptin back to where it was initially, that's going to, of course, relate to getting rid of the acute energy deficit, but that's also going to relate to refilling those fat cells, which, if the goal is maintenance, then you've got a difficult decision to make there. So, of course, getting back to maintenance is going to be helpful. Whether or not your leptin ever gets fully back to where it used to be, it may not. And in some cases, you don't need it to. So that's one thing to keep in mind, is that if you have a lot of extra body fat, you might have really high leptin levels, not just because the adipocytes are full, but you might also have a little bit of leptin resistance. So for a given amount of leptin, the receptors aren't responding in as pronounced a way as they otherwise would. You can think of it a lot like insulin resistance, how we see high insulin levels in people with a lot of excess fat tissue. And so one of the things that we might notice is that as you're losing body fat, your leptin levels might go down a little bit. And if you had a lot of body fat to lose, you might notice that your leptin sensitivity improves even as leptin levels are going down. So it might not have a big impact in terms of the actual activity of leptin, but at a certain point, when we talk about losing a ton of fat mass or getting down to a very, very, very low body fat level, at that point, we probably will see a reduction in leptin activity. After the fat loss is over, getting back to maintenance is going to help a little bit with leptin levels, but we still might find that they stay lower than they used to be. Okay.
Now that we're talking so much about leptin, I think a lot of people might be sort of asking, why is this leptin one of the most influential hormones when it comes to metabolic adaptation? What is the role of this when it comes to energy expenditure as well?
Yeah, so like I said, the main reason leptin matters is because leptin goes to the hypothalamus, binds with its receptor there, and then that really is largely how the hypothalamus perceives our relative energy availability, whether we have plenty of energy to use or not. And the hypothalamus is really the main control center when it comes to energy expenditure. So when the hypothalamus senses that we have really low leptin levels, then the hypothalamus influences a variety of different pathways in the body that reduces energy expenditure and ultimately works to conserve energy, because that's important for our survival as an organism. So we will see that resting metabolic rate will go down, again, because of that oversight and control from the hypothalamus that is largely dictated by leptin. So we'll see a reduction in resting metabolic rate, but probably the biggest impact that the hypothalamus has during low leptin conditions is on non-exercise activity thermogenesis. So we will actually subconsciously reduce our non-exercise level of activity. When you walk past the mailbox and you remember you should probably open it, when we're dieting really hard and very lean, we're probably not going back. Even the posture you maintain when you're standing or sitting. For me, one of the things that's really apparent when I do a bodybuilding competition and get very, very lean, so normally I pace a lot. I walk around the room whenever I'm thinking hard. Whenever I'm working, I stand up, I walk around the room, I think about what I want to write next. When I'm dieting, that doesn't happen anymore. And it's not a conscious decision, it's subconscious, and the hypothalamus has a lot to do with dictating the voluntary and the involuntary aspects of non-exercise activity thermogenesis. Now, the voluntary stuff we can override. We can consciously convince ourselves to incorporate more physical activity into the day, but ultimately those are the main ways that the hypothalamus is going to impact energy expenditure. And we see some downstream effects of that. So it's not that leptin is the only hormone that matters. We do see that when leptin goes down, it has an impact on a variety of different hormones that ultimately are dictated by the hypothalamus. So when we talk about endocrine physiology, we talk about hormone cascades. So there's usually 2 or 3 different areas of the body that are releasing precursors to the hormone that we're interested in, right? So the precursor to testosterone or estrogen or thyroid hormone. And so what we see is when leptin goes down, the hypothalamus senses that, it impacts a variety of different hormones as well. So testosterone, female sex hormones can be impacted. And specifically to your question about energy expenditure, we also see that thyroid hormone goes down as well.